Right under our feet lies the foundation of, well, pretty much everything, our entire global food system. And it's not just dirt, it's this incredibly complex living ecosystem that really dictates whether we thrive or, frankly, starve. In this explainer, we're going to dig into the science of soil fertility to really get a handle on one of the biggest challenges we face today. So, what's the secret to unlocking its potential?
This isn't some far off futuristic problem. This is the question for our time. Feeding over 9 billion people, that's going to require a really deep understanding of our most fundamental resource. And the answer, you'll find, is locked right there, inside the soil itself.
Okay, look at this. This comparison tells such a powerful story. On the left, you've got soil from the Netherlands. It's dark, it's rich, just full of organic matter that's built up over time. And then on the right, soil from Africa. It's just uniformly sandy, totally depleted of nutrients, and it's missing that crucial dark topsoil. And this isn't just one bad patch of land we're talking about. That kind of depleted soil, that represents something like 40% of African cropland. 40%. That's the scale of the crisis we're looking at. This is such a crucial point. And hey, if you're finding this explainer valuable, a quick like and subscribe would be amazing. It really helps us bring more of this content to you. So this whole challenge, it really boils down to one phrase: nutrient limitation. For thousands of years, farming just worked with nature. You'd leave fields fallow, let them regenerate. But today, the demands on our soil are just relentless, and its fertility has become the #1 thing holding back food production. For plants to grow, they need a whole menu of nutrients. But the big three, the macronutrients, are nitrogen, phosphorus, and potassium. You'll see them as N, P, and K. Now here's the thing. If a plant can't get enough of just one of these, its growth is stunted. Doesn't matter how much of the others are there. So the core problem of modern farming is basically managing this nutrient bank account. To really wrap your head around this, we have to take a quick trip back to the mid-19th century, to the work of a scientist named Justus von Liebig. He came up with a concept that was so elegant and so powerful that it's still fundamental to agricultural science today. And this is it, the law of the minimum. It's a simple idea, really, but it's brilliant. It says that growth isn't determined by all the resources you have available. Nope, it's dictated by the single scarcest resource, and that resource is called the limiting factor. To make this super intuitive, Liebig came up with this fantastic analogy. Imagine a barrel. Each wooden stave, or plank, is one of the essential nutrients: nitrogen, potassium, you name it. Now let's say one of those staves, phosphorus, is shorter than all the others. The amount of water that barrel can hold, that's your crop yield. You can pour all the water you want in there, but it can only ever fill up to the top of that shortest stave, phosphorus. If you try to add more nitrogen, you're just pouring it over the side. The yield won't increase until you fix that shortest stave. Of course, a real field isn't a perfect, simple barrel. Out there, you've got what's called heterogeneity, all these little variations in the soil, moisture, and sunlight. And what that means is, instead of your yield hitting a hard wall, the relationship is more of a gradual curve. But the basic principle, it's exactly the same. Okay, so that's the theory. But this principle has direct, real-world consequences for farmers, which we can get a handle on through something known as the yield equation. It basically helps us measure just how efficiently a crop is using the resources it's given. And a key metric here is something called initial nitrogen use efficiency. All that means is, how many kilograms of grain do you get for every single kilogram of nitrogen the plant actually absorbs? When nitrogen is scarce, the plant is incredibly efficient with it. But as you give it more and more, that efficiency actually starts to drop off. And this efficiency is different for different crops. Just look at this comparison. You've got C4 crops like maize. They are metabolic powerhouses. They can crank out about 100 kilograms of grain for every kilo of nitrogen they take in. Then you have C3 crops like wheat. They're a bit less efficient, producing around 70 kilograms. It really just comes down to C4 plants having a more advanced way of capturing carbon dioxide, making them super efficient in hot, sunny conditions. So as you keep adding more and more nitrogen, that yield curve starts to flatten out. And why is that? Well, you've solved the nitrogen problem. You've made that stave in the barrel longer. But now, another factor, maybe it's water, maybe it's sunlight, or even CO2, has become the new shortest stave. The law of the minimum is always at play. Okay, so if just dumping synthetic fertilizer on everything isn't a sustainable long-term solution, what is? Well, the answer might be to start working with nature instead of against it by tapping into one of the most powerful partnerships on the entire planet: Let's check out a real-world soybean inoculation trial from Western Kenya. This experiment tested a really beautiful, simple idea. What if, instead of adding nitrogen fertilizer from a bag, we could help the plants make their own?
And the results, they're just stunning. On the left, you see the control group, no inoculation. The plants are yellow, their growth is stunted. But on the right, the plants that were inoculated, it's like a different world. They have this luxuriant green biomass. They're almost twice as tall. The difference is just night and day.
So here's how this little bit of magic works. Legumes, like these soybeans, team up with bacteria called rhizobium. The bacteria set up shop in these little nodules on the plant's roots. And from there, they do something absolutely amazing. They take nitrogen gas from the atmosphere, which plants can't use at all, and they fix it into a form the plant can absorb. And in return, the plant gives the bacteria energy from photosynthesis. It's a perfect partnership.
And the results really do speak for themselves. The lead scientist on the trial summed it up perfectly. With this one simple inoculation, they saw a yield increase of 10 to 20%. Just like that.
Let's really put that number into perspective for a second. To get a 20% yield increase through traditional plant breeding methods, a breeder might have to spend a decade, 10 years of intensive work. Here, they did it in a single season, just by working with the soil's natural biology. And this brings us to one last really provocative question. We've seen how powerful biological nitrogen fixation is in legumes. So, what if we could engineer that incredible ability into our staple crops that can't do it, like wheat and rice? It could fundamentally change agriculture as we know it and our ability to feed the world. There's a lot to think about there. So make sure you save this explainer so you can easily come back and review these concepts.